All right, IBAASL2. Today's kind of a short one. We're just going to talk about cumulative frequency graphs. So I'm going to lead you through how to create a cumulative frequency graph just by doing an example with you guys. So the problem is a group of 80 athletes run laps on a track, and then they run a certain amount of laps and then they tap out, and then how many laps they ran is then recorded. We don't have the raw data for this problem, but we do have a grouped frequency table that shows the number of laps that certain people took. So like when I look at this, there was one person that did between 0 and 10 laps. I don't know if it was 1 or 2 or 3, 4, 5, 6, 7, 8, 9, 10, but I know it's somewhere in there. I also see that 20 people did between 10 and 20 laps, and 31 did between 21 and 30, and then 21 people did between 30 and 40, and 7 people did between 40 and 50. The way you construct a cumulative frequency cumulative frequency curve. Sometimes IB calls it a polygon, but we're calling it a curve today. Even though it's not curved, it's made up of line segments. So let me show you how to do this. First, if we're going to create a cumulative frequency curve, you need cumulative frequency. So the original table does not have cumulative frequency. So I'm going to add a CF on the side here. Remember, to find cumulative frequency, it's just a running tally of the frequencies that you've acquired so far. So in the problem here, we only have one frequency so far, but then you add 1 and 20 together to get 21. Sorry, wait, this is 1 to get 21. So it's like 20 plus this 1 is equal to 21. Then we're going to add 31 to that. So it's like 31 plus 21 is 52. 21 plus 52 is 73. And then 7 plus 73 is 80. Now that number 80 should sound familiar because it said there were 80 athletes in the problem. So this number right here should always be your total frequency, which is how many data points you have in the problem. Another way to say that is sigma f. It's all the frequencies added together. I don't like where I put that. I'll put it over parentheses. Sigma f is the same thing. Okay, we're going to take the cumulative frequency row in this case and then translate it onto this graph. Before I start putting points on this graph, notice that on the y-axis I have cumulative frequency. So because it went all the way up to 80, I had to make sure my y-axis goes all the way up to 80 as well. Then in terms of the x-axis, we're doing number of laps. This should be your actual raw data scores that come from up here. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Now we're going to start building this cumulative frequency curve. And the way you do this is you plot points and then play connect the dots. The mistake I'll see from people is that they'll be like, well, this first column right here from 0 to 10 is 1. So at 0, they'll put a dot on 1. But this is not the way you want to do this. This means, this whole box means from 0 to 10 that you grow from 0 up to 1, that there's one data point at the end of the interval. So as I zoom in right here, that means we start at 0, 0, and then at 10, we need to have one data point. Then I connect them with a line. So you get a little triangle that starts at 0 and grows to 1. I realize with a frequency of 1, it's kind of hard to see what the difference is anyway, but picture if that first frequency was like 15 or something like that, then the graph would change dramatically in the beginning. The next interval says from 10 to 20 that it grows from 1 to 21. So if I look at the interval 10 to 20, it's going to grow from that 1 that it already had up to 21. So if I trace up here at 20, it'll be 21. Now you're going to want to be as accurate as possible with these graphs because later on you'll be asked to use the graph to figure out something about the problem. So yeah, your sketch, I really want you to be as accurate as possible. The next interval is 20 to 30, and this says from 20 to 30 that it grows from 21 to 52. So if I go back to the 20 to 30 interval, which is right here, it's going to grow from 21 up to 52. So if I trace up, that means it's right about here. Then from 30 to 40, it grows from 52 to 73. So at 40, which is the top of the interval, I should land at 73. So 73, I'm tracing over till it hits right about here. I think that should line up with 40 and line over here with about 73. Yeah, that looks good. So let's connect the dots. And then I'll get rid of my little, so it's not confusing later, because later we are going to use this graph for something. Then the last interval says that we grow from 73 to 80 over 40 to 50. So at 50, I should end at 80. So if I trace 50 up and then 80 over, I think the last one is about here. All right. This is your cumulative frequency curve. Even though it's not really curves, you're kind of just connecting the dots. Although I'm noticing in the book that they kind of throw a little curve on it. Like, oh my gosh, are they doing it wrong? No, they start at 1 there. They just didn't connect it to the beginning. For some reason, the book doesn't show this little segment right here. They just start immediately at 1, which I guess you can do, but I like to always enforce that you start with 0 and then you grow up to the first number. So let's go ahead and do it like that. It's still the same graph. It's just theirs would be like this. It would be like missing this first. Oh, no. Missing this first chunk right here. But I think it is part of the curve. Yeah, but it's interesting that the book does kind of put a little curve on it. They make it go like something like this, which is fine. It's going to be about the same thing anyway, but really you're just connecting the dots. So connect the dots is fine. Now, the last part that I did not write down. Oh, no, I did write it down. It says right here. Use it to estimate the mean and IQR of the number of laps. So we need to figure out the mean and the interquartile range from this graph. Okay, you guys, there are 80 pieces of data in this graph. Let me clean up some of my highlights here. I know there's 80 pieces of data in the graph because the very top frequency is 80. Now, the mean, if you have 80 pieces of data, is going to be in between the 40th and the 41st, or it's going to be the average of the 40th and the 41st. So in terms of your graph, you can just look at 40 right here, because it's very close to in between the 40th and 41st. And then we'll trace that over, maybe I'll use a different color. So it hits the graph at right about here. Then you drop a line down to estimate what this number is. It's very close to 25, although I think it is a little bit past 25, so we're going to say 26. certainly on a test, if you put 25 or 26 or 26.5 or even, 27 or 24, I would still probably give that full credit. Now, if you were like, it's 20, it's 30, I'd be like, well, no, you didn't graph that right. So 26 is the mean. Now, the inner quartile range is going to be Q3 minus Q1. Now, the first and the upper and lower quartiles are going to be the medians of the upper and lower half. So if we look at just the lower half, there are 40 pieces of data in the lower half. So the median is going to be in between the 20th and the 21st. So if I trace over from 20 and put a little dot or an X right here, I guess I was doing X's, and then drop it down. Ooh, what is that? Let's see. It's past 15, closer to 20. I'd say 17 or 18. Yeah, let's say 18. See, this is why your graph has to be as accurate as possible, because like just a little bit of like fudging on that is like, it'll change your number dramatically. Now, in the top half, there are also 40 pieces of data, so it's going to be in between the 20th and the 21st of the top half. So 20 beyond 40 means that it's in between the 60th and the 61st. So if I trace over from 60, that hits here, and then I'm going to drop it down. What do you guys want to say? 34? I think it's 34. So that means the inner quartile range is 34 take away 18, which is what, 16? The last thing I'm going to show you is something about percentiles, because I'm not even sure if it comes up in the homework, but just in case. So sometimes you might hear somebody say like, I scored in the 90th percentile. Now, this doesn't mean that they got a 90 on their test. It means that they scored in the top 90%, or not the top 90, they scored basically in the top 10% of people taking the test. It means that they were better than 90% of the scores in the class or the group of people that took it. So, if you want to figure out a percentile, like let's say you have 80, like with our runner data up there, if you have 80 data scores, and you want to find the 90th percentile, you'll multiply 0.9d, whatever, times 80. And, sorry, didn't keep my calculator on me. So this equals 72. So this is the 72nd piece of data. So, for instance, back to my graph up here, if I wanted to figure out what the score is for the 90th percentile, I would, here we'll go in red, go to the 72nd score, which is right about here, and then trace it over to the graph. Which is maybe around there, and then drop it down. So that would mean like the 90th percentile is about 42 laps or something like that. So with my example, 90th percentile is 42 laps. So you basically just multiply your percentile as a decimal times the total frequency, and that gives you its location. And when I mean location, I mean it's like, oh, it's the 43rd piece of data or something like that. It's not the actual number. And then you can locate it either from your table or from your cumulative frequency curve or anything like that. All right, guys, happy studying.